Now let's talk about the square law modulator as a type of AM modulator. As I said earlier on, in amplitude modulation, we need only two signals, which is one, the message signal, and then the two, the carrier signal. These are the two signals that we need. So getting these signals, we are using this carrier signal to carry the message signal to our destination. And therefore, in this case, we are going to use the nonlinear device as our modulator. So it's like, it's like getting, you want to do a, let's say, pancake or meat pie, right? And then you have the necessary ingredients, which is maybe the flour and then the various type of meat that or the egg that you want to put inside. Let's assume that we can't use our hand to do it. We have a machine for that, right? We are assuming that we can't use our hand to do that, make that meat pie, but after getting the necessary raw materials, we have a machine for that. So your flour is one of your raw material, and then the egg or the meat will be another one, which is also your raw material. When you put them into the maybe microwave or any other device which can be used to make that meat pie, that becomes the machine that you are using to make that meat pie. The same thing applies to here. We have a message signal as our raw material which we want to transmit, and then we have the carrier which we want to use to transmit this message signal. And for that case, we want to modulate the signal in such a way that when it's going, we will not experience any attenuation on the way because of the higher frequency and the higher amplitude of the carrier signal. So in that case, we need to put it through a modulator, and this method of generating the AM wave, the square law modulator, we have a nonlinear device such as transistor and diode as our modulator. So in all, I'm going to get you a simple diagram. Let's say this is our NLD, nonlinear device. This is our input, which is let me do it, input, which is U of t, and or let's say V of t. Let me do it, V of t. And then this, it's my output, which is what? V out or V naught of t. These are outputs. Yes. So after you have passed it through nonlinear device, I was telling you earlier in my previous video that because of the nonlinear nature of these devices, at the end of the day, the output, most of the times they integrate some harmonics inside, which is the integral multiple of the fundamental frequency. And this happened because of the nonlinear nature of the device, in this case our modulator. So bringing that to whatever we are doing right now, we assume that our message signal and the carrier that we are using for our transmission, it's our fundamental frequency. Let's assume that at the end of the day, when it comes out after the modulation and there is an integral multiple of this fundamental frequency, which is the original message or the original signal that we place into the input of the nonlinear device, due to the harmonic nature, the harmonics that the nonlinear device created, it means that we have gotten an unwanted frequency or unwanted noise being added to the original signal that we want to modulate, and therefore we need to filter it out. So if you remember in one of my videos, I said that this is the main reason why after modulation, we pass the output of the nonlinear device through a bandpass filter. And you know, in a bandpass filter, we need a cutoff frequency. We set them for it with the various ranges, frequency range. So if you are low frequency, it's 20 Hz, and then your high frequency, it's 20 kilohertz. We can generate a cutoff frequency from this, and then we will use it to design our bandpass filter in such a way that it will actually attenuate whatever frequency that the nonlinear device will bring, or whatever noise that the nonlinear device will bring into the system, either with a low frequency or high frequency, due to the harmonic nature of the device. So in this case, I'm going to draw a block diagram for this simple illustration. So in all, what I'm trying to say is that in AM modulation, if you have your carrier signal as I represented it earlier in one of my videos, which is C of t, and then my message signal, which are the signals that we need for our modulation. These are the summer. We pass it through the nonlinear device, and in this case the nonlinear device, as I use the meat-pie analogy, it's our modulator. Because of the harmonic nature of the nonlinear device, there will be an integral multiple of the original message that we place in to be modulated, and therefore we need to pass it through a bandpass filter in order to remove such frequencies. So after all, you pass the outputs, which is V0 of t of the nonlinear device, into a bandpass filter, and this is V1 of t. And at the end of the day, you are going to get your AM modulated signal or wave. You are going to get your AM modulated signal, which I represented it as S of t. So this is a simple illustration of the square law method of generating an AM wave. So thank you for watching, and see you in my next tutorial.